Quadratic versus exponential. In this video, you'll learn how to explain using graphs, tables, or calculations that exponential functions eventually grow faster than quadratic functions do. So a quadratic function is in the form y equals ax squared plus bx plus c. And an exponential function is in the form y equals a times b to the x power. So let's practice looking at some different types of functions. In pattern A, the length and width of the rectangle grow by one small square each step. And in pattern B, the number of small squares doubles from each step to the next. So we can see in pattern A that in every step we add one row and one column. And in pattern B, we're doubling in each step that we add. Let's look at each pattern a little closer and decide if it's an exponential or quadratic pattern. So in pattern A, we start with 0 squares, and then we go up to 1, and then 4, and 9. So if we wanted to write this as a function to see how many squares we'll have after a certain step, we can write this as f of n is equal to n squared, because we just squared the step number that we're on. Now let's look at pattern B. So we have 1 square, and then 2, 4, and 8. So if we want to make a function for this one, we can write it as f of n is equal to 2 to the n power. Since we're doubling on each step, we just change the exponent. So we can see that pattern A is quadratic because we have an exponent of 2, and pattern B is exponential because our exponent is the variable. Now that we know the function for each pattern, we're going to use them to fill in this table. So we're given the step number, and we'll write how many squares would be in that step. In pattern A, we would start with 0 because we're just going to square each step number. 1 squared gives us 1, and 2 squared gives us 4. 3 squared will give us 9. 4 squared will give us 16. 5 squared will give us 25. And 6 squared will give us 36. Now let's look at pattern B. So we're going to raise 2 to the power of the step that we're given. 2 to the 0 power would be 1, since anything to the 0 power is always 1. And then 2 to the first power would be 2. 2 to the second power would be 4. 2 to the third power gives us 8. And 2 to the fourth power gives us 16. 2 to the fifth power is 32. And 2 to the sixth power is 64. So we can see that pattern B is growing a lot faster, and this was our exponential function. Let's look at another example. Tyler completes the table comparing values of the expressions 5x squared and 2 to the x power. So we can see that Tyler filled out this table for all x values between 1 and 4. And 5x squared has a lot higher values than 2 to the x power. Tyler concludes that 5x squared will always be greater than 2 to the x power for the same value of x. Do you agree? We can see that the values for 5x squared are a lot higher for values through 1 through 4, but let's try a higher number like when x is 10. Then we'll replace x with 10 and 5x squared, and 10 squared gives us 100, and multiplying that by the 5 gives us a value of 500. Now let's look at 2 to the x power. So we'll replace x with 10, and 2 to the 10th power will give us 824. So this is actually higher now than the quadratic. So all exponential functions will eventually be higher than the quadratic. In this example, function f is defined by f of x equals 1.5 to the x power, and function g is defined by g of x equals 500x squared plus 345x. What function is quadratic? Well, we can see that g of x is the one that has a squared term. So g of x is a quadratic function. Now we're going to create a table of values to show that the exponential expression 3 times 2 to the x power eventually overtakes the quadratic expression of 3x squared plus 2x. So we'll fill in this table for all x values from 0 to 5. So for 3 times 2 to the x power, we'll replace x with 0, and anything to the 0 power is always 1. So 3 times 1 will give us 3. Now we'll replace x with 1, and 2 to the first power is just 2. Multiplying that by the 3 that we have gives us an answer of 6. Now we'll replace x with 2, and 2 squared gives us 4. Multiplying that by 3 gives us an answer of 12. Now we'll replace x with 3, and 2 to the third power is 8. Multiplying that by 3 gives us 24. Now we can see that the pattern is just doubling on each step. So when we go to x is 4, we can just double the 24 that we have, which would give us 48. And then we can double that again for x equals 5, and we'll get 96. Now let's look at the quadratic expression of 3x squared plus 2x. So we'll replace x with 0, and 0 squared is still 0. So adding 3 times 0, which is 0, and 2 times 0, which is also 0, we would just get a value for 0 for that one. Now let's replace x with 1. 1 squared will give us 1, and multiplying will give us 3 plus 2, so we'll have a value of 5. Now let's replace x with 2. 2 squared gives us 4, and multiplying gives us 12 plus 4, or 16. Now we'll replace x with 3, and 3 squared gives us 9. Multiplying gives us 27 plus 6, or 33. Now we'll replace x with 4, and 4 squared will give us 16, and when we add the products, we'll get 48 plus 8, or 56. And on our last one, we'll replace x with 5, and 5 squared gives us 25, so we'll have 75 plus 10, giving us a value of 85. So we can see that the exponential function did take over, and its values were a lot larger heading towards the end. Now let's summarize what we've learned. Quadratic functions change with a factor that gets closer and closer to 1 as the input to the function gets larger. Exponential functions always grow with the same factor. So if that growth factor is greater than 1, then the exponential function will eventually grow faster than any quadratic function will.